Hi everybody and welcome. Today we're going to be talking about the area and volume of spheres. So this is going to be actually our last new skill before taking the state test. So congratulations on getting until this point. Of course, there's still more to do after we finish the state test because that's not the only thing that we're taking this course for. But again, quite a few skills we've gone through so far. So you should feel, if you've gotten to this point and you felt pretty good about most of the stuff, you should feel pretty proud of yourself. So first thing, area of a sphere. Formula for this. Our entire surface area is calculated as 4 times pi times the radius squared. So just a quick reminder, our radius is from the center to an edge. So not all the way across, but just halfway across here. So we'll do two examples. Starting here and going across, this is in fact a radius. So we simply take our formula and replace the radius with the number that equals the radius. So we have 4 times 81 times pi. So go ahead, punch that into the calculator. 4 times 81 is 324 times pi, and that is square centimeters. So this is like if you have a basketball and you're trying to put wrapping paper around it. The wrapping paper is the area. It's that kind of like two-dimensional shape. So that's kind of the coating of this sphere. For our next one, if we look, going all the way across this sphere is 14. So because it goes all the way across, that's not a radius, it's a diameter. So we have to go from our full diameter all the way across of 14 to our radius, which is half of that. So once more, 4 times pi times our radius squared, 4 times pi times that value of 49. So we'll get 196 pi square inches for our surface area here. Now the nice thing about a sphere is it's just the area. There's no lateral, there's no base, it's just the entire surface area the first time through. So a few extra steps are saved here, which honestly should make our life just a little bit easier. After getting the area or coating the outside, we need to look next to the volume. So for this formula, volume equals 4 over 3 pi r cubed. So again, take your radius value, identify it, and plug into the formula. So 4 over 3 times pi times 9 to the third power. Now, something to note, this is the third power, so not just squared. So it's not 9 times 9, it's 9 to the third, or 9 times 9 times 9 again. So we'll have 4 over 3, 9 to the third is 729 times pi. A trick to doing this is you can make this into a fraction. So you can do 4 times 729 and then divide that by 3. So our final answer here will get 972 pi cubic centimeters, because this is a volume, we are filling the entire shape. So basically, as long as we can identify the radius, we just plug it on in and we can get to volume from there. Next up, this is a diameter going all the way across. So take that diameter, divide it by 2 to get radius. So in this case, again, 4 over 3 pi times that radius to the third power. So we got 4 over 3 times 343 over 1 times pi. So multiply it by 4, divide it by 3, and we'll get our answer of 457 and 3 repeating, or in 1/3 pi inches cubed. You also might see this left as the fraction. So another way to write this is because it doesn't divide out evenly, they might just leave it as 1372 over 3 pi cubic inches. Those are the same thing. So the only thing is 457 and the third is that 1372 over 3. So those are the same number. One has been divided, one hasn't. You might see it either way on the state test, so just wanted to note that here if it doesn't divide out evenly. So those are the two formulas to focus on for